Okay, haven't decided on a name for this video yet, but I'm sure I'll come up with one. The basis of this video is kind of similar to a video I made recently, but I'm going to show something I didn't show in that video. Hopefully the sound is loud enough. I can't speak too loud because my flatmate or housemate is in bed. He has work in the morning, so excuse me. I have to only speak at the level I'm speaking at, so you'll have to maybe turn up the volume if you can't hear me. And I know my accent doesn't help matters either, so I get that. But it is what it is. I can't change it, so it's up to yourself. So I'm going to go through the nonsense that our opposition have to do to try and come up with an elevation angle that they can then move to their equatorial plane. So this would be the equatorial plane would be there, right? This black line. I'll come back to that in a minute. But also to address their straw man that they use with us. And it's just the reason they use the straw man of where do you get your height? How come you can't calculate a height to the celestial body, blah, 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 with your right angle triangle. The reason they use this is a way of avoiding the fact so we don't focus on this nonsense that they have to do. They don't want us focusing on this nonsense, which is not correct geometry. But it's what they have to do, right? So they take the focus away from their rubbish and try and place it upon the real world thing, which is a right angle triangle. That's what an elevation angle is. A depression angle is a right angle triangle. A zenith angle is also a right angle triangle. But the thing is that they don't want to address the fact that they also use right angle triangles, and especially when they bring this angle here to the center of their globe, it's because of when they bring it there, let's just say within the annual calendar, and what happens then when it is there. That's a video for, or that's something for another video. So I'm not going to go into the equatorial plane issue here, but I want to address something that they don't. It's basically something that they try to explain away for themselves that destroys their paradigm, but it's also something that destroys their straw man to us at the same time. So quickly, just first, I must just go through a few citations. Okay, of what an elevation angle is, right? It's always a right angle triangle. This line here between these 2 points, that's the vertical that you're measuring. That's the measurement. It's not this that you're measuring. You're measuring this here from that distance. So this vertical height here, angular height, vertical angular height, is what's being measured from this distance. That's what it is. Angle of elevation. It's a vertical measurement. Angular measurement, right? Now, your angular measurement is going to be an apparent height because it's an angular measurement, right? We all know this, but yet our oppositions don't seem to get that. An apparent height, it's always an apparent height. The only time you can turn it into a real height is via calculation based off of your distance from the object and knowing the height of the object. Other than that, you can't turn it into an actual height. It will always only be an apparent height. Okay? So but for them to deny denying the right angle triangle means they're denying the elevation angle. They're denying the actual measurement itself because the measurement is a vertical measurement. It's a vertical measurement that's perpendicular to a horizontal plane. And this is what they don't realize, our opposition don't realize is going on. They seem to be avoiding that. When they say to us, it's not a right angle triangle, that means that they're denying that they're actually measuring an elevation angle. Because that's what an elevation angle is. You're literally the part of the thing they're denying. They admit to this line here and this line here, right? Well, that would be a tangent for them. But they try and say it's just 2 lines meeting at a vertex. No, it's not. It's not just 2 lines. It's not just an angle. It's very specifically an elevation angle. And the elevation part is this opposite here. the adjacent, the hypotenuse, and the opposite. It's the opposite that you're actually measuring, and this is the thing they're denying, right? Our opposition are denying the very thing that's being measured. This is how ridiculous it is. And it's a measurement above the surface of a GP point on the surface of Earth. So it's a vertical height above that in angles, right? It's an angular, a vertical angular height, right, above that point, right? That's what you're measuring. So how could you not have an opposite? How could it not be a right angle triangle when it's the vertical that you're actually measuring, right? So this is what we're dealing with. Our opposition deny the very thing that they actually need, the very thing they're actually measuring. So it's like measuring a table and then denying the existence of the table. It's like you've just measured it. That's the very thing you were measuring, the length of the table. You know, and that's not even a stretch. That's literally what they're doing when they're denying that an elevation angle is a right angle triangle. Now, of course, in what I'm going to show here, they're going to talk more about the trigonometry side of it, right, which is the straw man they try and use against us. But it's okay because I'll go through all that. And when they say, can you calculate a height? So you should be able to calculate the height to the celestial body, you know, with your angle or whatever. Yeah, we can. We can calculate a height. No bother. But the height is going to be different, right? Because with every angle we take, because the angle will be different. So if I have a 44-degree angle, a 38-degree angle, and a 52-degree angle, I'm going to get 3 different heights. Because I have to, because especially when I'm doing it, when I'm taking these angles, if I'm taking them and I'm using the celestial navigation method, then I'm only looking for the horizontal distance. So if I use those 3 different angles and I go and get the horizontal distance, which is the adjacent length, which is all I'm looking for to get me started, that's the measurement I'm looking for. Then based off of that, the angle, then if I use trigonometry after that, then I will have 3 different heights, right? And I could take the same angle, or sorry, I could take 3 different angles at 3 different times to the same star, and I'll end up with 3 different heights, because they're vertical angular measurements, and they're to a celestial body that I don't know the actual height of. So I will get 3 different heights to the same thing. I have no idea what the actual height of the thing is. But this is the problem. They don't understand that you need to know the actual vertical height of the thing before you could even try to do trigonometry. So there's no point in them talking about trigonometry after we've gotten the horizontal distance we're looking for. Why would you be wanting to know the height of the object, the star or whatever it is in the sky at that point? You wouldn't. But the point is that you don't know the vertical height to it. If you were here and it was at your 90, right, how do you determine what height it is? How do you go vertically straight up from the GP point of Polaris up to Polaris? How do you do that? You can't. Right? And there's obviously a second reason why it would be pointless, and I'm going to show in a minute, right? But this is the straw man that they don't seem to understand is a pointless straw man. It's just a diversion away from their pathetic position, basically. So moving on, here is another, right, elevation angle. What is an angle of elevation? It's another right angle triangle, because you have to have that 90 degrees. You can't have a 90 degrees with just a horizontal. You can't have that. A 90 degrees is going to be horizontal and a vertical, and it's a vertical measurement. So how can you not have the vertical? How can you have a 90 without a vertical and measure a vertical without the vertical? It makes absolutely zero sense. Here, I just want to point out on this one, right, that let BC be the building. This is like 2 separate, there's a 60 degree and a 45 degree angle. And AB be the transmission tower. So let's say from B to C here is the tower or building, and from A to B is a transmission tower on top of the building or whatever, right? So, or that's the full height of the from A to C is the transmission tower, from B to C is the building, right? So they're two different heights. Two different heights, 2 different objects. And when you know those heights, you would have to know the height of the tower or the height of the building, sorry, or the height of the tower. You'd have to vertically measure the things, or measure them horizontally before you erect them up, whichever, right? You have to know those heights to be able to use the angles to determine what distance you are from the things. That's the only way you can do it with trigonometry. If you don't know that vertical height, the vertical height, the thing they're denying measuring, our opposition, right? If you don't know that, how are you going to gain an actual height to it via an angle? You can't. It can't be done. It's impossible. So they're trying to strawman us with an impossibility, basically. Moving on, more angles of elevation and depression. Here we are, right? Ground horizon, 90-degree angle. There's the altitude, slant range elevation, blah, 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 right? It's a right angle triangle. There's no denying it. That's what an angle of elevation is. Here we are again, angle of elevation. Once again, right angle triangle. All the time. It's a vertical measurement with a 90 degrees, right, angle. You need a right 90-degree angle. So how are you going to have a 90 degrees without a vertical? How are you going to measure a vertical without measuring the vertical? It makes no sense that they try and strawman us with this, that they deny this. Well, it makes sense to them because it means that once they accept that, it means that they're accepting the surface of Earth is a flat plane, and they're not going to do that. Once again, hypotenuse, adjacent, opposite, right angle triangle. Here we have it again, right angle triangle. And once more, object, horizontal line, right? The angle of elevation formula is no different from the formulae of trigonometric ratios. With the help of the formulae given below, we can find the angle of elevation depending on which two sides of the triangle are known. For example, if we have to find the angle of elevation when the height of the object from the horizontal line if we have to find the angle of elevation when the height of the object from the horizontal line and the length of the line of sight are known, we can use the sine formula, right? But the point is that if I used, there's another part to this page, and I also have it here now, is that this horizontal line is always directly underneath the object. So here is the observer, here is the horizontal line, the baseline, and it's always directly underneath the object. So if this is his angle to Polaris or to a star, then that means that horizontal line extends all the way, not to just the horizon, all the way to underneath the object, because that is the vertical that's being measured. That's how an elevation angle works. Okay, so enough of this part for the moment. We'll move on to the more juicy stuff. But the point being is that there is no denying that it's y that's being measured. The vertical, that is what you're measuring, the vertical. So when our opposition are denying that an elevation angle is a right angle triangle, when they're denying that, it means they're denying the actual measurement that you're making, which is the vertical. You're making a vertical measurement to determine the horizontal length, right? It's not done the same way as trigonometry. It's done differently, but that's the point. You can't determine the horizontal length without measuring the vertical. So how can you deny the existence of the vertical? You'll never get the horizontal length you're looking for. If the vertical is, I'll use a simple one, is 45 degrees, then you know then once you do your calculations or do your conversion that the horizontal distance between the observer and the GP of the celestial body is 2,700 nautical miles. You know that because you've measured the vertical to be 45 degrees. So I don't see how people could possibly deny that, the existence of the vertical. I don't know how they can deny that and sleep at night and look in the mirror in the morning. I just don't know how people can do that. Okay, this is what the nonsense they must come up with, right? What they do is, here you have a 90 here, I have a tangent here, right? 90, right? That's the GP of Polaris. Here you have an observer, right? And they have a 45 degree, right, angle here to Polaris, right? Because what they do is they must claim that all the light from their sun is coming in parallel, right? And what that actually is, right, all that parallel light actually is your line of sight. So how this works for them, right? I have this fixed, so I can't move this up and down, or this one up and down. I haven't fixed. I'll come back to this in a second. But how they work this is this, right? here is how it works. Now I'll have to mess around with this a little bit because just to give it just to make it correct. This is Polaris here, right? But also Polaris is here and here and here and here, because they're claiming that there's parallel light rays coming in, right? So it's not that there's lots of Polarises, it's just that the light from Polaris is coming in parallel to hit the surface of their convex surface of their globe. So this blue line here, this is a tangent, right? That they're placing, touching their globe at one point, right? And what they're trying to say is that as the observer moves north, let's say the observer goes to there. Now I'll have to move this as well because otherwise it won't be coming in straight, right? Then they get this angle, right? So the angle increases as they move north. And if they keep going north, right, eventually they'll get a 90, right, or whatever, right? So that's if they're at the GP point of Polaris, right? If they move south, they're moving, right? So when they're moving north, they're moving up over the arc of the globe, right? But as you'll see that tangent never leaves. So every step they make, that tangent is there, right? Whether they're going forward or back. In a boat, as they're walking, anything, that tangent is always ever present. So at no point ever is the surface of that globe here. At no point is that being referenced. It's always the tangent. This tangent is a big, massive, monstrous tangent, and no matter what happens, that follows that person, right, or boat or whatever, right? So as they go south, right, as you can see, I'll go right down to here, and I'll have to move this just to make it more correct, right? As you can see, it's a 36-degree angle. Now, if I just go in slightly, right, 36-degree angle, right? But it's only because this line is coming straight down, right, to meet this tangent that's at an angle, right? Let's just say that's at an offset angle to what would be a straight line, horizontal, right? As the person or whatever goes north, right, once again, that line will be straight down. So it's all straight lines coming down to meet their globe, and it's meeting the tangent at every time. So as the tangent changes, right, as the point moves along the surface of their globe and the tangent goes with it, that allows them to, right, claim an angle. But all that's really the reason, let's just say the reason, because they're claiming it's parallel light rays coming into their globe. The reason that they're getting this 37-degree angle is, according to them, is because Earth curve is now getting in the way, right? Yet Earth curve is not being addressed in any way, shape, or form. There's no Earth curve being addressed. It's all off at the tangent. But what they're saying is that as you go north or south like this, so the more north you go, let's just say on the globe. Now I'm not going to keep moving the top one, but you get the gist. I just put the top one over there for a minute. The more north you go, right, the closer you get to 90. As you go south over their globe, your angle to Polaris becomes smaller and smaller. Why? Because Earth curve is claimed to be getting in the way. Now, all they're actually doing, right, with this, is inserting mathematically a globe in a place that where it doesn't exist, and hijacking your line of sight, because that's all that actually is. If you put a person standing here and take a line straight out to here, right? If you have a person standing and take a line straight out to there, then that's just their eyesight. That's just their angle, line of sight to Polaris. That's all it actually is. That's what they're actually hijacking. So this is what they must do to hijack your line of sight. And they're calling your line of sight parallel light rays. There's no such thing as light rays. They don't exist. They're purely mathematical. They don't exist. So, but they're trying to insert them. So how it works out as, sorry, it's my cat, one of my cats, is they have an arc length distance here, right? Now, I've equaled that arc length here in a straight line on their tangent. And what what that works out as, if I bring it down a bit, is you end up with this. So what if I straighten that up? I can't do it here now, but if I could straighten this up to put this, make this green serrated line here between this point here and this point here, if I made that horizontal, then this would just be an angle, a hypotenuse angle up to someone's line of sight, angled line of sight to Polaris, right? So all they're doing is hijacking your line of sight. That's all any of these lines here are. They're hijacking of your line of sight. So if you were here at 90 degrees, right, below Polaris, right, or Polaris is at your 90, sorry, then this is just your line of sight to Polaris. You look straight up to see Polaris, right? When you're here, right, when you're here at that distance away from Polaris, you'll have a 45-degree angle to Polaris. So you won't have to look straight up. You'll be looking at it at a 45-degree angle, because this here will be your baseline. Now I showed a few minutes ago there that they're also using a flat baseline with their moving tangent, because their tangent just follows the point on their globe. They're constantly using this baseline here, but then trying to hijack your line of sight, because that's all that is a line of sight. That to that observer here, it's just their line of sight. So it's not a parallel light ray from their sun, which goes back into nonsense from Eratosthenes that I'll go into in another video. I've addressed it thoroughly in the past, but I'll be addressing it again because it's the start and end of their globe. Right? Why do they need to claim these parallel light rays? The reason they need to claim these parallel light rays is there's a couple of reasons. Right? The main reason is that what Eratosthenes did was measure. See this here, this elevation angle. He measured an elevation angle. That's why. So to get away from the fact that he just measured a horizontal baseline, right, of 500 miles, what he had to do was start talking about the shadows, right, and how shadows. The only way shadows can work, the shadows we see in reality, the only way they can work, anyway, mathematically, on the surface of a globe, and they don't even work. And I'll go into that maybe in my next video. How they don't work on the surface of a globe, but the only way to mathematically somewhat make them work is to make the light from the sun come in parallel and hitting their convex globe surface. But that's what they're also using here with Polaris, let's just say. They're trying to use the same thing here with Polaris, but all these lines, see all they actually are, right, these parallel lines, they're not parallel lines. In reality, what they actually are is that if I could move this orange dot here forward and back on this green line here, sorry, if I could do that, then the angle to Polaris up there would be changing, and each one of those would just be your line of sight. So that's what they're doing. They're just hijacking your line of sight. So when you look at the sun, they're claiming that your line of sight is one of their parallel sun light rays. It's not. It's just your line of sight. That's all it is. It's what they've hijacked, and they're trying to basically use a hose down your back and then tell you it's raining. It's not. That's my line of sight that you're trying to tell me is some parallel light ray. It's not. It's just my line of sight, and that's what they're doing, because this will be the outcome of it. In reality, you're after measuring a 45-degree angle, so you're measuring that in reality off a horizontal plane. That's what's actually going on. You're not doing this. This is not happening, right? None of that is happening, right? With this following it, that is not happening. You're not doing any of those things. That's not happening in reality, right? As you can see, this is why they don't want to address the vertical. This is why, because if you can see within their claim, there's no vertical, right? There's no vertical in their claim. They're trying to avoid the vertical, whereas in reality, there is a vertical. There it is. That is what, right, you're actually measuring with an elevation angle. And they try to strawman us and say to us, what's the, okay, if you're using a right angle triangle, then you'll be able to calculate the height to the celestial body. Haha, right, this nonsense, right? Yeah, we can calculate the height to the celestial body, as I said earlier, but the heights are going to change when the angle changes. It's an angular height. Every time you move a distance from every time, whether it be the base. Let's say this is here. Let's say I'm just going to go up to this one. Let's say this one here is the base of a tower, right? That's the right. There's the top of the tower, and there is the person, right? Even if we just use basic trigonometry, if this person moves closer or further along that horizontal baseline to the tower or away from the tower, the angle is going to change. So your angle will change. You'll have a different angle each time, right? A different angular vertical height. Now, if you don't know the height of that tower, you can't use that vertical angular measurement or vertical angular height to determine the actual height of the tower. It doesn't matter if you know this line here, right, and this line here, if the tower is not there. If you're only addressing a point up here, then it makes it, how can you say that that point, if you can never vertically measure between here and here, how can you say that that point here is this height based off of that triangle? You can't, especially if it's a point that you can't get to and it's something that you don't understand and you can't recreate, you don't know the composition of, you don't know how it does what it does. How could you ever make that claim? You can't. But there's a bigger problem, right? What they must do, right, to address, right, the fact that when you leave, if you take an angle here, let's just say, right, when you are in an airplane here or above, let's say a hot air balloon, anything, right, above this point, and you're taking an angle to the same celestial body, you get the exact same angle, right? So how does that work with our straw man, right? I'll come back to this in a second. So how will that work with your straw man? How are we going to know the height with that, right? 1 second. So if I just come over here, sorry now. Right. So here we have three right angle triangles with a shared base, a shared opposite, right? So here is the observer, right? This is the ocean. Here is the GP point of a celestial body. Here is their angle to the celestial body, which places the celestial body there. So is the vertical height, right, of that celestial body between here and here, right? And if it is, then how come when this person here is standing on a mountain and takes an angle using an artificial horizon, right, that their distance to the same celestial body, right, at the same time or whatever, is exactly the same. But they're on the top of a mountain, right? So they're whatever, let's say they're 3,000 feet above mean sea level, right? But that places the celestial body up here then. So what's the height of it now? Is it between here and here? And if the height of it is between here and here, then what's this height between here and here? And let's say the person is in an airplane or another person's in an airplane and they're taking an angle and an angle to the same celestial body at the same time, and they're obviously, because it's the same angle at the same time, or taking an angle at the same time, they get the exact same angle, which gives them a distance to the GP of that. But then it places the celestial body up here, right? So which one of those is the height? Is the height from the bottom here up to the top? Is it from this line, this red line here up to the blue, top of the blue hypotenuse? Is it from the green one here down to the blue one? What is it, ballers? You see, this is the thing. Our opposition try and strawman us with this nonsense, but the fact that when you go up in altitude, you get the same exact angle, that gives you the exact, if you want to use trigonometry, then if this is in a boat at sea level, this is on a mountain and this is in an airplane, then you're getting the exact same height, right? Using this, if we use trigonometry after we've gotten the distances along the adjacent, right? After we've gotten the horizontal distances, which is all you're looking for. If we then use trigonometry in those three situations after that, then we get the same exact height to the same celestial body. Yet, how can that be when these are 3 points at 3 different elevations? This is 0, this is 3,000 feet, and this is like 6 miles, whatever. Height. So how can How can I measure the height to something that keeps rising as I rise with it? How can I do that? I can't. It's impossible to do it. Yet, this is what's being measured. The vertical is what's being measured. So it just happens that we are measuring a vertical to something, but the thing we're measuring a vertical to is so elusive and bizarre that it that it keeps rising with us as we rise. So how can you ever know the height of something is if it keeps going up as you go up. That's like wearing a helmet with a GoPro on it, right? And that GoPro was sticking out from the top of the helmet, going out in front of just above someone's forehead. And that person's trying to measure the height from where they are up to the GoPro, from their feet up to the GoPro, right? From the ground up to the GoPro, right? But then they go up in, let's just say, up in a hot air balloon, and they can measure it again. But how? What's the point? It's like the GoPro has risen with the person. So how are they going to determine what height the GoPro is off a sea level if the GoPro keeps going up as you go up? Because it's like the celestial body is attached to you. So as you rise, it rises. How are you going to measure the vertical height to it? You can't. But that doesn't mean you're not measuring a vertical, because you're still measuring a vertical. The vertical is still being measured. You just can't measure the vertical height of the celestial body, because it rises as you rise. Just like the horizon appears to rise with you as you rise. It doesn't actually rise with you, but it does appear to do so. Now, the celestial bodies do something similar. Whereas as you rise, they appear to rise with you. That's where you get the same exact angle to the same celestial body. So this person here, right, taking an angle to Polaris will get 45 degrees at sea level. At the same latitude, this person here on the mountain will get 45 degrees. And at the same latitude, this person here in the airplane will get 45 degrees. So which one of these people has the correct height to Polaris? The answer, none of them. And if we add it all together, will we have the correct height? No, none of it is correct. We don't know the height to Polaris. We don't know the height to any celestial bodies. And the reason we don't is because you can't. You can't know the height to something that keeps going up as you go up. It's not stationary for you to measure the vertical height of it. But you're still measuring an apparent vertical, an apparent angular vertical height. That's what you're measuring. Whether you like it or not, ballers, that's what's being measured. So how can you deny the right angle triangle, right, when you're literally measuring a vertical? It doesn't matter if you can't measure the actual height to the celestial body, because you're not looking for that in celestial navigation. But the point is, you're still measuring a vertical. So how do you expect to use the straw man on us when you are fully aware that the celestial body appears to rise as you rise in altitude? So why would you use that straw man when you know it's completely dishonest? In my last video on this, I was attacked by one or two people, or maybe more than one or two. I didn't read all the comments for verbally attacking them. It's like, well, why shouldn't I? Why shouldn't any of us verbally attack ye if you're going to be so dishonest that you're going to keep on using the same straw man, right? That in a way that you know, like concerning a topic that you know that the answer to. You know we can't measure the height to the celestial body because it keeps rising as we rise. So how can we do that? So if you're going to be dishonest and use a straw man with us constantly that you know is completely fraudulent and you know is completely dishonest, then why shouldn't we just abuse you? At least we have a reason to abuse you, because you don't seem to understand that you're making an elevation angle as a vertical measurement. Right? You're denying the very thing that's being measured. As I said, it's like denying a table when you've just measured a table. I measure the length of the table, then I deny the existence of the table. Then what do they measure? So if you want us to stop thinking of ye as being stupid and stop calling you stupid, the step one would be to stop being dishonest. Stop trying to hit us with this straw man that means absolutely nothing. That something that you know is a total straw man. All it is an attempt to try and waste our time The stop, you're trying to hold back the tide. You can't hold back the tide. Elevation angles are right angle triangles. That means in each one of these circumstances, this one, and this one, right? This an angle to the same to Polaris from 45 degrees north will always give the person at sea level on the mountain and the airplane the exact same distance to the GP point of Polaris. But the problem is that they can accept, the ballers, they can accept this one and this one up to a point. They can't accept this one because that's the surface of Earth. That's sea level. They can't accept that one because that means that you are measuring Earth to be a horizontal plane. Not that you're measuring this or you're measuring this, which can later on be can be after measurement. You can curve that. You can curve that around the surface of a globe, but you can't do this with that or that with this because this is sea level. The site reduction tables, I keep saying this, in the Nautical Almanac, the point of the site reduction tables is for precision of your elevation angle, right? So if I take an angle to something at a particular time, to a particular time take an angle at a particular time to a particular celestial body, right? What the site reduction tables do is they tell me that at that time my actual angle, right, once I've kind of worked out my position, my actual angle, right, my three angles to that celestial, or my three angles to those three celestial bodies, what they actually were was let's say my first angle was 2 minutes 14 seconds out. It should have been whatever instead of whatever I got. It's a precision thing. And what do they use as the adjacent for the site reduction tables? For best precision, they pre-assume, right, the Nautical Almanac pre-assumes that mean sea level is the adjacent of the elevation angle. Three straight lines, 190 degree here, and adjacent, hypotenuse, and an opposite. So this line here is what the Nautical Almanac is pre-assuming that is the adjacent. So they're not using a curved anything. They're pre-assuming that mean sea level, which is basically the Nautical Almanac is telling you the Earth is flat. It couldn't be more clear. It couldn't be more clear, right? So I don't know what else to say to you. You're not getting this as usual. You don't want to get it. But I have one other little thing I must point out here, right? So besides all this, which destroys that straw man, there was one other thing I want to point out here. And I've gone into it in the past, right? As you can see here, right, before I finish, I've shown this right angle here, right? You can see here, I have a second 45 degree angle and a little line here, right? Now, I could do the exact same thing with this angle that I did with this angle here that I did with this one. I could extend this out to here, right, this line here, and bring that line up and put another dot here, and that would be an extension of this. But it would just be, as I showed earlier, it'd be as you raise, because this is a risen position, right? As you raise, then let's say Polaris, if you're at 45 degrees, right, north latitude, then Polaris will appear to rise with you as you rise. So let's say this is it from an airplane or something like that. If this person here on the boat is claimed to be getting a 45 degree angle to Polaris, not just because there is parallel light rays, remember, which is the hijack of your line of sight, but because Earth curve is getting in the way, then how come the person in the airplane is getting 45 degrees if Earth curve is not getting in their way? They're 6 miles above, so Earth curve is not getting in the way. So this completely removes Earth curve, because at this point, Earth curve has absolutely nothing to do with their claim. Their claim is all based around the hijacking of your line of sight. That's what it is, and trying to call your line of sight some kind of a a part of a parallel sun ray or parallel light ray. That's all it is. So how can the Earth curve, the curve of a globe Earth, be getting in the way of this person here, right? While they're trying to take an angle to whatever, this celestial body, right? And that's the reason why, as I just showed over there, look, as I just showed, as that person goes down, the angle decreases. As they go up, the angle increases, right? If it's to, let's say that's Polaris, I'm just going to put Polaris there, right? Put it there as if it's Polaris. So there is 90, right, or close on it. The person goes down over the globe. And what's changing the angle? Obviously, they're using the tangent, right? So, right, obviously in reality, that's just a horizontal. But what are they trying to say? That the person is traveling over a convex surface, and that's giving them a more shallow angle. Are they coming up over it, and it's increasing the angle? So down over it decreases the angle, up over it increases the angle. This is what they're trying to claim, right? Right. So within their claim, there is this big geometric globe Earth in the way. But when we come over here to the airplane, there's nothing in the way. So what they're trying to claim then is there's no Earth curve involved in that. There is only Earth curve claim involved in this, but not in this one. That's the person that's in the airplane, right? But yet they're also getting 45 degrees. So the only thing they can do, basically, when it comes to an airplane, all they can do is say, well, the pilot's line of sight is a parallel sun ray. That's all they can say. They have nothing, because there's no Earth curve getting in the way. They're 6 miles above, right? So there's no way. There's literally no way, because the whole parallel sun rays thing, or light rays, is a joke, because there is no light rays. Light is not a ray. It's purely mathematical heap of nonsense that they must add in. But the point being is that there was no Earth curve in the way of the pilot. So why are they getting 45 degrees? If you take away this nonsense about light rays, right, it completely debunks the globe. Well, it debunks it anyway, because there is nothing getting in the way. The pilot is not going up and over or down and over a globe. There's none of that happening. The pilot is getting the pilot in the airplane at 6 miles above is getting 45 degrees, just like the person below them is getting 45 degrees when they're at 45 degrees north latitude. They're going to get 45 degrees to Polaris. Yet there's no Earth curve getting in the way. So that means that there's no, that means before opposition shall shout, but the parallel light rays, because they're idiots. That means there's no Earth curve getting in this person's way either. But this is the person that is supposed to be standing on the surface of the globe. So if this person in the airplane here, let's make this a bit bigger. If the person in the airplane here, right, can get 45 degrees without any Earth curve, right, then that means the person in the boat is getting 45 degrees without any Earth curve being involved. So there's no Earth curve involved. That's basically what you're trying to claim. I don't care what you're trying to say, but it's about light rays, things that don't exist, right? Light is not a ray. Light is not a ray. It's been established. See quantum mechanics, right? So it doesn't matter what they say about that, because if the person in the airplane is getting 45 degrees and there's no Earth curve involved, then that means that the person below them in the boat is getting 45 degrees and there's no Earth curve involved. There's no Earth curve involved because there is no Earth curve. It doesn't exist. It doesn't exist. The globe does not exist. It's not. It's added in afterwards. It's always a mathematical afterthought. After real world measurements have taken place, it's a mathematical afterthought. Because they're trying to make you believe that the observer is here and the GP point of Polaris is here. And what? There's an arc between you? No, there's not. In reality, the GP point of Polaris will be here. And this line here would be a horizontal going across the screen there. That's what it would be. That's the truth of reality. Not this nonsense. Right? There isn't two tangents. Right? That doesn't, right, where one moves closer to the other. And eventually when one comes up to there, they line up, and then the two tangents, as the person goes back down over the globe, the tangents start deviating again. No, none of that is happening. It's heap of rubbish. They're hijacking your line of sight. They're trying to tell you that the airplane pilot doesn't need Earth curve to get 45 degrees. But then they're trying to say that the reason the person in the boat is getting 45 degrees is because of Earth curve. Look into what they claim concerning Polaris and the globe. It's purely based off of, oh, our curve is in the way. If our curve is in the way, then how come it's not getting in the way of the pilot? Yet they're getting 45 degrees. It's because it's not getting in the way of the pilot, the same way as it's not getting in the way of the person who's on the boat at sea. Because it doesn't exist. It's that simple. Now, I've laboured it enough. Hope you enjoyed the video, and thanks for watching.